An interesting and important question we will tackle in this video is what is biomechanics, followed by its application throughout the real world. My name is Humaira Niazi, and this is the final project for Life Sciences 4Y03 with Dr. Dowling. What is biomechanics? Biomechanics is a subdiscipline of kinesiology that looks at biological systems and their mechanics. Biomechanics is defined as the application of mechanical principles in the study of movement for all living organisms. In other words, biomechanics is the science that is concerned with analyzing how and why bodies move in the way they do. It is a relevant field when understanding injuries and prevention by analyzing force, range of motion, and inertia. It is a combination of engineering, biology, and physiology. It is an interdiscipline of many subjects. Subjects that are helpful and relevant to biomechanics include anatomy and physiology, physics, math, and biology. Anatomy and physiology are necessary, especially in human biomechanics. Anatomy and physiology provide a thorough understanding of bones, muscles, and joints. It also provides an understanding of human motion and forces that are relevant in understanding mechanics and human disorders. Physics is needed because it helps determine the mechanics of a biological system. Relevant subdisciplines of physics include thermodynamics, fluid mechanics, and solid mechanics. They are necessary to concepts in biomechanics, specifically forces, motion, and inertia. Math is necessary to understand the biological angles and complete mathematical calculations in biomechanics. Lastly, biology is important, especially when applying biomechanics to non-human animals. Biology provides the necessary foundational knowledge for biomechanics in these non-human animals. Biomechanics is an applicable field that can be applied to numerous careers. Let's start off with insurance. Biomechanics can be a tool for insurance workers or private doctors working for insurance firms. This is because biomechanics can provide an advantage in detecting malingering and faking symptoms. Malingering is essentially faking of symptoms or exaggerating them in order to avoid work or gain financial benefits. An example of this could be an individual faking their symptoms after a car accident to increase financial benefits from an insurance company. In situations like these, private investigators and insurance workers need to figure out how to detect this malingering, and biomechanics can help with that. Malingering can be detected by biomechanics because biomechanics provides the foundational knowledge in detecting maximal strength. By measuring the manual strength of an isometric contraction, we can determine if an individual is faking their maximal strength. When one is maximally contracting their muscles, they should have some sort of tremor around 5 to 10 hertz. If there is no tremor present, it's an indication that someone is faking their maximum contraction and they're actually stronger than they're showing themselves to be. Knowledge of biomechanics also helps us understand that if there's a variability in strength output, in maximal strength output, then perhaps the individual is faking it. Biomechanics also gives individuals the understanding of how endurance time and EMG work together. It is known that maximal effort can only be maintained for a few seconds, and EMG increases as muscles fatigue. An EMG is a tool that measures electrical activity of muscles. With this knowledge, it can be detected whether individuals are faking their maximal strength and their maximal effort. Biomechanics can also be applied to the field of forensics and criminology. It can be an important tool for detectives or private investigators as well. When investigating a crime scene, biomechanics provides essential tools in criminal detection. Biomechanics can analyze forces and range of motion techniques in a crime to determine the guilt or innocence of a suspect. For example, if an individual gets a blow to the head, by analyzing the forces of the blow and the damage caused to the victim, biomechanics can determine if the suspect was physically able to produce that force. Biomechanics can be used to determine and verify the likelihood of a story. Biomechanists can assess if an injury could have been caused by the way a witness has claimed, or whether the damage caused must have another source. Biomechanists can do this due to the understanding of force, tissue tolerance, and injury. For example, if an individual claims a situation was an accident, such as a victim fell and got hurt rather than being hit in the head, biomechanics can analyze forces to determine the likelihood and possibility of this statement. Detectives can also use biomechanics for crime scene analysis. It can help analyze footprints or tracks left at a crime scene, and it can be used to determine height, weight, foot type, and movement patterns. Biomechanics can also help analyze bullet wounds by examining tissue damage and determine the initial bullet velocity. This can assist in narrowing down the type of gun used at a crime. It can be used to determine the direction and angle of blood splatter in order to locate the origin of the injury. Biomechanists can also analyze the walking or gait pattern of a suspect to determine if they committed a crime. If you're interested in solving murders and mysteries, biomechanics offers great insight. An example of biomechanical knowledge used in solving a murder is the famous John F. Kennedy assassination. Biomechanics help reconstruct the scene of the crime and gauge deeper understanding around the debate of how many bullets were used. For individuals interested in detective work, biomechanics provides an advantage in solving crimes. Biomechanics can also be used in industry by an occupational health and safety consultant. These consultants can aim to reduce vocational activity damage. When someone works in one position for a long period of time, there's risk of damage. For example, an individual who constantly sits on a computer may develop carpal tunnel syndrome. In industry, there's also risk of sudden injury due to unsafe practices. This is harmful to the individual and the company as a whole. Consultants can prevent these injuries by analyzing a workplace and introducing changes that will lead to long-term benefits. Consultants can also suggest necessary changes that must be made to create an overall safer environment. A consultant may suggest that the desks in a workplace be placed higher to support improved posture in workers. Biomechanics can also provide the tools to create relevant and valid pre-employment screening practices to ensure vulnerable individuals are not put in dangerous situations. By incorporating suggestions, changes, and pre-screening, biomechanics can assist consultants in making the overall workplace safer. Prosthetic development engineers and prostheticists also require biomechanics. A prosthetic is a fake limb often provided to amputees that mimic real limb function. Biomechanics helps determine the design of a prosthetic. Prosthetics must be connected to a patient without being too tight and preventing circulation. It should also be able to carry a load, and biomechanics can ensure these qualities are met. It is also necessary for alignment of the prosthetic, and biomechanics can help with this by quantifying the necessary symmetry, ground reaction forces, moments, and energetics for walking to ensure the prosthetic is correctly aligned and ensure comfortable use. Prosthetics is a field where emerging knowledge constantly helps individuals' lives. Biomechanics can help amputees in continuing their day-to-day activities, thus improving not only their physical health, but their mental health as well. Another field where biomechanics is extremely helpful is orthopedic surgery, specifically for fractures, joint replacement, and implants. Biomechanics can help determine the large forces that these replacements must be able to withhold in order to ensure effective use and prevent further harm. By analyzing free body diagrams and dynamic equilibriums, forces on bones can be calculated. Biomechanics can also be helpful for implants by providing an understanding of what materials should be used based on the activity levels and bone stress of an individual. When orthopedic surgeons conduct joint replacements, the artificial joint must be provided the normal range of motion and be able to withstand large joint reaction forces. Biomechanics provides insight into the normal range of motion and indicates how joint replacement surgery can be altered to assist this. For example, by slight manipulation of joint placements or alteration of muscle origin and insertion, individuals can be more comfortable post-surgery. An understanding of biomechanics also provides a more thorough understanding of the risks associated with implants. For example, biomechanics provides insights of the problems associated with using high-density implant material. In conclusion, biomechanics is a broad field that is relevant to many aspects of the world around us. Careers in biomechanics include fields of healthcare, forensics, industry, safety, and many more. To summarize this video, biomechanics is a relevant and applicable science that is helpful in many careers and fields of work. Biomechanics is the study of humans and human motion, and it is beneficial to detecting malingering, detecting criminals, improving safety, developing prosthetics, and enhancing the realm of orthopedics. Studying biomechanics can equip you with the tools relevant to various careers and day-to-day lives. Considering this is a kinesiology class, I recommend all students to look into their future career goals and analyze how biomechanics can be an asset in that. The following references were used for this presentation. Thank you for listening.